Well, good evening. Today we'll discuss 1 and 2 marks questions of the board examination. First problem, March 2014. Shall discuss 1 mark and 2 marks questions of the board examinations from 2014 to 2024. The first question of 2014, evaluate integral sin x plus cos x dx. You cannot expect a simpler question than this. You know integral of u plus v is integral u plus integral v. You need not write that also. So you can integrate sin x, what do you get? Minus cos x. And you can integrate cos x, what do you get? Sin x plus c. See, after 2023, they have included this in objectives. So then they would have given the answers. You can tick. There's an indirect way of working this also. Supposing you are not good in integration, you take the 4 answers given, differentiate it. I should get back the problem. For example, I differentiate cos x. We know the derivative of cos x is minus sin x. Therefore, minus cos x derivative is sin x. I get this. Now, derivative of sin x is cos x. So, this another method I am explaining you. Nowadays, after 2023, the pattern has changed. These papers had no 4 answers. Now you have got 4 answers with you. So what you can do is but differentiate. You have to get back the problem. But one thing is important: you should know how to differentiate. Otherwise, you can't help. So what I am telling you, in case if you are got it up, whatever answer you have got, differentiate that and see whether it is the problem. We'll move on to the next question. July 2014. This is 2x minus 3 cos x plus e to the power of x. Another direct problem on the formulas. 2 is a constant, x is x square by 2. So 2 into x square by 2, or if you are very good, you can write it as x square. Minus 3 is a constant, cos x is plus sin x only. And e to the power of x is e to the power of x plus c. The only place where you may go wrong is by integrating cos x. Because differentiation cos x minus sin x, we get a confusion, but I've been repeating this number of times. In derivatives, the functions start with c, have a negative answer. Whereas in integration, the answer is starting with c. Here, answer is not starting with c. You should have a positive answer, but there is a minus sign that is written. So we'll move on to March 2015. Compared to the earlier problems, this is somewhat different. See, while doing revision, I told you I've given you most of the formulas. In case if there is any formula which we have not covered, then we get a problem on that, we'll explain it. So there's another formula you have got to remember. E to the power of x into f of x plus f dash of x dx is equal to e to the power of x into f of x plus c. So remember this formula, very important formula. Whenever you notice e to the power of x in integration problem, multiplied something else. Always first thing is maybe of this type. The problem may need this formula. They will not give directly. For example, here they have e to the power of x, but this is not in order. That you have got to arrange it. How to arrange it? E to the power of x you keep it as it is. X by x square is 1 by x minus 1 by x square. Repeat, x minus 1 by x square is that you can separate the terms. You get 1 by x minus 1 by x square. So you can, if you are a good student of integration, you know what is differentiation rather. Because you can, if you take this as 1 by x as f of x, if you differentiate it, you get this. The answer is e to the power of x by x plus. So always note in integration, whenever there is a problem with e to the power of x, we may have to use this. Not always. But first see this. If it doesn't occur, then we can think of other problems. So let's go further. Now we have to move on to July 2015. The problem given is integral of secant x into secant x plus tan x. In fact, this problem has been repeated at least 2 or 3 times. 2 or 3 different years. A very simple one. You arrange it, you multiply this, you get secant square x. You multiply this, you get secant x tan x. Remember, in integration, you have to first bring it integrable form, then only you must integrate. What is integrable form? It's in the formula. When you look at this problem, it is not in that format. Now see what is secant square x? It is in integrable form because you know it is tan x. What is secant x tan x? That's also integral form. Is secant x. You can even cross check. Differentiate tan x, you get secant square x. Differentiate secant x tan x. So normally with very simple problems, very next year, that is March 2016, they have given a similar problem. Instead of secant x, they have given cosecant x. And it is cosecant x into cosecant x plus cot x. Procedure is same. You multiply, you get cosecant square x plus you get cosecant x cot x dx. For the integration of cosecant square x, it is minus cot x. And this is minus cosecant x. Yes. So we move on to July 2016. July 2016. The problem given in July 2016 is much simpler. Integral of 2x square plus e to the power of x. You cannot expect a problem simpler than this. Most direct. 2 is a constant. X squared is x to the power of 3 by 3. What the formula we are using? Integration of x to the power of n is x to the power of n plus 1. A simple formula. 3 by 3. And e to the power of x is e to the power of x plus. So from July 2016, we will move on to March 2017. March 2017. The The problem given in March 2017 is root x plus 1 over root x. Root x plus 1 over root x. You have to arrange it in a proper way. Root x you can write as x to the power of half. You can write root x as x to the power of half. 1 over root x you can write it as x to the power of minus half. One over root x is not in integrable form. So I have to bring it integral form. What is that? This formula x to the power of n. What is n in first case? It is half. So it is x to the power of half plus 1 divided by half plus 1 plus. What is n in the second case? Minus half. Same formula. X to the power of minus half plus 1 divided by minus half plus 1. See, half plus 1 is 3 by 2. This solve with 3 by 2, you will get 2 by 3 x to the power of 3 by 2. This is 3 by 2, but 2 will go to numerator. Minus half plus 1 is plus half. That means it is 2. Minus half plus half is plus half. Minus half plus 1 is plus half. Is 2 root x plus. So we will move on to July 2017. What is July 2017 problem? Much simpler than the earlier years. It is cos 3x. If you look at the list of formulas I have given you, a formula. Cos ax dx is sin ax by a. In differentiation, we differentiate ax and multiply by a. In integration, we differentiate ax and divide by a. That you should remember. In differentiation, cos 3x is minus 3 sin 3x. And that 3 we got by differentiating 3x. So there we multiply, here we divide. And one more thing, integration of cos is not negative. Integration of cos is positive. The differences of cos is negative. So what is your answer? Sin 3x divided by 3 plus c. So we will move on to March 2018. March 2018. The problem in March 2018 is x cube minus 1 by x square. There is no quotient rule in integration. You simplify and then integrate. How to simplify? You can separate the terms. You get x cube by x square minus 1 by x square. X cube by x square is x. And 1 by x square you write it as x to the power of minus 2 dx. So integration of x is x square by 2 minus x to the power of minus 2 plus 1 by minus 2 plus 1 plus c. This is x square by 2 only. Minus 2 plus 1 is minus 1. Therefore, it will become plus. And minus 2 plus 1 is minus 1. You can write this is the answer. X square by 2. Even if you write this and leave it, they have to give the marks. But in your case, that is not required at all, because now after 2023, you have got objective questions. So they would have given the answer in this format. Therefore, you can't leave it like that. Up to 2023, there was no objective. So we are supposed to integrate and keep it. Here, up to 2023, things have become very easy. So the answer that you get should be one of the four given there. Therefore, you need to simplify. So we move on to July 2018. July 2018. It's a problem we have already worked. You can refer back and see we have worked this problem in July 2015. So I have repeated the same problem. So I will move on to March 2019. March 2019. The problem given in March 2019 is integral of 1 minus x into root x dx. So in the earlier year, they are given divided by something, here multiplication. To simplify this, 1 into root x is root x, but write that as x to the power of half. And root x into x is x to the power of 3 by 2. Because you see, x into x to the power of half is x to the power of 1 plus half. That is x to the power of 3 by 2. That is simple algebra. Then write that x to the power of 3 by 2 and dx. Now, for the integration of x to the power of half, x to the power of half plus 1 by half plus 1. What about 3 by 2? X to the power of 3 by 2 plus 1 by 3 by 2 plus 1. See, half plus 1 is going to be 3 by 2. So you can write this as 2 by 3 x to the power of 3 by 2. 3 by 2 plus 1 is going to be 5 by 2. So you can write that as 2 by 5 x to the power of 5 by 2 plus. So July 2019. July 2019 problem is secant square integration of secant square 7 minus x. Don't look at 7 minus x, you just look at secant square. What's the integration of secant square? It is tan x, but x they have not given. So you should write this as tan of whatever they have given. Afterwards, as I said earlier, ax you should differentiate, you get a, you are going to divide. Here also you are going to differentiate 7 minus x. When you differentiate 7, you get 0. When you differentiate x, you get 1. There is a minus sign. Therefore, you can write minus here. Divided by minus 1 is same as minus of this. This problem is given, especially some of the students get 99 in their last marks here, careless. You have to remember, this is purposefully given just to confuse you. So remember, whenever the function is not in standard form, secant square x, you can write tan x. So supposing they are given secant square 8x plus 3 and asked to integrate this. So remember, secant square is tan. So whatever is there, you write 8x plus 3. Then you should differentiate 8x plus 3. You get 8. So divide by 8, 1 by 8. So you can do one more thing. If you are given directly secant square x, just look at secant square. That is tan x is there, write x. Differentiate x, you get 1. Will not change. If you practice that, then these things should be avoided. In differentiation, we multiply with the derivative of that whatever function is there. Integration, we do the reverse of it. Divide it. There you multiply, here you divide. So secant square x is also you can use this formula. Just look at secant square, it is tan. X is there, write x. Find the derivative of x, it is 1. It will not change. So if you remember that, these problems you will not lose marks. These are the areas where the 1 mark question many students lose marks. So I am highlighting that. Remember that. See, if you can take care of the areas where we are likely to lose the marks, then definitely getting 100 is not a problem. You can refer back to your previous year's question and then examination, preparatory examination, other examinations, and find out these are the areas you would have asked the marks. So be cautious whenever you have such problems. Okay, with this we move on to March 2020. I don't know why the examiners repeat the same problem without even changing. See, they have given x square, no, 2x square plus e power x. I did not got this problem because this problem, same problem, we have given in July 2016. So we move on to March 2021. March is over. So July 2020. What's the problem in July? So the examination was not held in July that year. It was held in September. September 2020. The problem was root x plus 1 over root x. Root x plus 1 over. In fact, same problem was asked in the year March 2017. So they repeat the same question. Even then, some of the students was asked. Now, we are working there. Let's move on to March 2021 exam was not held because it is Corona. So we had exam in September 2021. What's the problem? 2x minus 3 cos x plus e power x. You can very well see we have worked the same problem in July 2014. Please, they would have changed the numbers, even that they have not done. The problems are repeated as it is. So from September 2021, we move on to April 2022. April 2022. 2022. I will not be working this problem because 2 different years they have asked the same problem which we have already worked. So we move on to next problem, August 2022. That also no need of working. That's the first problem that we worked today. That was July 2014. Now we move on to March 2023. March 2023. This is somewhat a good problem. The problem is e to the power of x into secant x to 1 plus tan x. It's a good problem. It makes you think a little. I've told you, whenever e to the power of x is there, you always first step you think this may be the problem. This may be the problem. Yeah, definitely that's the problem. You can write this as e to the power of x into secant x plus secant x tan x. This is f of x. This is f dash of x. If our answer is e to the power of x into f of x, what is f of x? You can express. Not a difficult one, but it makes you to think. Now the same problem with a small change I have given in July 2023. They have given e to the power of x only, but I have given sin x plus cos x. So you should realize which is f of x. Cos x cannot be f of x. Because if you differentiate cos x, you are going to get minus sin x. There is no minus sign. But if you differentiate sin x, you are going to get cos x. So this is f of x. And this is f dash of x. And this is the power of x in sin x. So two consecutive years, they have repeated the same concept. And August 2023, same problem. Then model paper 1. Model paper 1, the problem is e to the power of x into 1 by x minus 1 by x square. We have already worked the problem, but they have given in this form x minus 1 by x square. But both are same. So we already got that, no need of working it. And model paper 3, we have given the problem dx over x into square root of x square minus. This is secant inverse x plus c. So especially it will be easy for you. Supposing you are not able to recognize this, 4 answers are given. You differentiate the answer. Provided you remember the derivative of secant square x is 1 over, secant inverse x. Secant inverse x is 1 over x into root of x square. So if you are good in differentiation, some of the problems of integration can be solved because they give you the 4 answers of the answers you can get. So with this we will move on to 2 marks questions. 2 marks questions. We will start from March 2014. The problem given is sin square x over 1 plus cos x. This will be a difficult problem provided you have not worked earlier. In examination, you cannot think of this. So, a very simple problem if you know the formulas of trigonometry. What is sin square x? It is 1 minus cos square x. The reason behind working the examination problems is you familiar with these kinds of problems. If you have completed all the previous examination papers problems, so about 50% of the questions are repeated. Sometimes they repeat as it is, or the same concept they would have used. That is why you have to go through the previous problem. The reason behind I am solving this problem, so that at a time you are getting all the different questions of 1 mark, 2 mark. And if you are familiar with this question, the moment you see the problem, you can work it out very easily. For example, sin square x is given. You know it is 1 minus cos square x over 1 plus cos x. Simplification is not over. You can further simplify. You can write this 1 minus cos x into 1 plus cos x. A plus b into a minus b, a square minus b square. So denominator 1 plus cos x. These two will cancel. Integration of 1 is x. Cos x is sin x. Minus cos x is minus sin x plus c. It will become a very simple problem for you, provided you have seen this, you would have worked We move on to July. No, normally they give two problems of 2 marks. The other problem is the most simplest problem. You can't expect a simpler problem than this for 2 marks. It is log x. Of course, here you cannot guess for the answer because 4 answers are not given. So expert remember, to differentiate log x, you get 1 by x. Therefore, you integrate 1 by x, you get log x. So we'll go on to July 2014. So we get 1 mark, 1 question, 2 marks, 2 questions. This is another very interesting problem. Sin x into sin of cos x dx. I've given you a formula f of x into or f dash of x, or you can say f of g of x, I'll get the formula like this, into g dash of x dx. So here, put cos x as t. When you put cos x as t, you get minus sin x dx equals dt. That is sin x dx is minus dt. So this sin x and dx can be replaced by dt. So the problem becomes minus a, you can keep it outside, sin t dt. It's a problem on substitution method. So when you differentiate cos x, you get sin x. So that you should realize. Now what is the integration of sin t? It is minus cos t. There is already a minus sign, plus cos t plus t. So we solve this problem by substitution method. After integration, the substitution must be replaced. If you don't do that, you are going to lose 1 mark. So what is the answer? What is t? T is cos x. Cos x plus c. So every year they give 2 marks, 2 questions of 2 marks. So July 14, 1 question I got. Let me move on to second question. You should realize the problem given was the problem of method of substitution. The second problem, somehow every year they give a standard result only, 1 plus x square. Any student will know it is calculus. If you don't know, please know. That's all I can say. The next problem is little interesting. That is March 2015 problem is really, of course, this problem is there in your NCERT textbook. Cos 2x minus cos 2 alpha divided by cos x minus cos alpha. See, you cannot write this problem in the examination. You should have worked this earlier. These are all standard problems. So you know a formula. Cos 2a is 2 cos square a minus 1. Of course, there are other formulas also. This formula is suitable here. So we write cos 2x as 2 cos square x minus 1. Same formula is applied. You get 2 cos square alpha minus 1 divided by as it is. You can't simplify this or need not simplify this, keep it as it is. If you are tempted to use a cos a minus cos b formula and all that, that will not help us. So you cannot take a chance in the examination. You should have seen the problem. That's why we ask students to work the previous year's examination papers. Just at least just recall what methods are employed. So let us simplify this. This is 2 cos square x minus 1 minus 2 cos square alpha plus 1 divided by cos x minus cos alpha. So this minus 1 and plus 1 cancels. 2 is a constant, you can take it outside. Cos square x minus cos square alpha is cos x minus cos alpha into cos x plus cos alpha. A square minus b square is a plus 20a minus b. The denominator is cos x minus cos alpha. So this will cancel. Now 2 is a constant, keep it outside. So the integrated cos x, that is sin x. You have to integrate cos alpha, it is not sin alpha. Alpha is a constant. So keep the constant as it is. Sin alpha. Then f1 you should take as x. Cos alpha is a constant, keep it as it is. Integration of 1 is x. This problem, normally many students lose marks if they are not worked this earlier. Once you have worked, the moment you see, oh, this is the method, oh, yeah, take cos square alpha, denominator cancels. So that is why we insist on working the previous year question papers at least twice, not once. You can work more than once, you become more familiar. Let's move on to the second question of March 2015. The second question given is x minus x root x. None of the problems are difficult, but you should have worked earlier. You take root x common, you get root x minus 1. Put root x minus 1 equals 2. You will get 1 over 2 root x dx. Difference of 1, derivative of 1 is 0 dt, or 1 over root x dx is 2 dt. So this root x and will replace by 2 dt. So 2 you can keep it outside. It is dt. By root x minus 1 is t. So standard integral, that is 2 log t plus c. Integration by substitution. Once you complete the problem, you replace substitution. What is t? Root x minus 1. So invariably, one of the question is going to be, most probably, we cannot say always, but substitution method. The other question will be normally the standard form. So with that, we will move on to July 2015 paper. July 2015. Every year they give 2 questions. Normally one question from substitution, another question standard result. So July 2016 paper is x square of July 2016. X square over 1 plus 1 minus x to the power of 6. 1 minus x to the power of 6. You have to copy the problem properly. If it is 1 plus, the formula is different. So here this also, if you have worked earlier, that will be easy for you. The method is, you can write this problem x square over 1 minus x cube whole square. Now put x cube equals t. You get 3x square, and when this is x square dx equals 1 by 3 dt. I am avoiding one step. Whenever we are going to get 3x square, you can shift 3 there. So what is the problem now? You can replace this x square dx by 1 by 3 dt. So 1 by 3 is a constant, let us keep it outside. Dt over 1 minus t square. Now we need a formula. What's the formula? A square minus x square. It is 1 by 2a log A plus x over A minus x plus C. Here A is 1, x square is t square. So what do you get if you apply the formula? 1 by 2a. 1 by 2a is 1 by 2. 1 by 3 is already there. It becomes 1 by 6. A is 1, therefore 1 by 2 remains. 1 by 3 is outside. Log of what is A? A is 1. X is t. 1 plus t over 1 minus t plus c. The problem is not over. You have to replace the value of t, otherwise you lose 1 mark. 1 by 6 log of what is t? X cube. 1 plus x cube or 1 minus x cube. Comparatively, it's a lengthy problem, but not difficult. You need to remember that which formula to be used, and if you remember the formula, it is not difficult. The second question is, I think 2 different years they have asked this question for 1 mark. Now they have asked this question for 2 marks. It's a familiar question. E to the power of x into 1 by x minus 1 by x squared. The answer is e to the power of x by x plus f of x plus f dash of x. F of x 1 by x, f dash is 1 minus 1 by x squared. So we have worked this problem already. So we move on to the next problem of March 2016. 2016. The problem given in March 2016 is not difficult, but you should have worked this earlier. Dx over sin cube x plus cos cube x. In fact, while doing the revision, I have taken about this problem. Unless you know how to work, you cannot think of the method in the examination. The problem should be familiar to you. It becomes familiar only by working. As I said earlier, work the question paper at least twice. I write this one as sin square x plus cos square x divided by sin cube x into cos cube x. So sin square x plus cos square x is 1. So we need to remember we have to use this formula. What is the next step? Separate it. Sin square x over sin cube x into cos cube x plus cos square x over sin cube x into cos cube x. Unless you have worked this problem, you cannot work with the examination. You can't just think of the method there. The method should be familiar to you. Now, sin square x will cancel. So 1 sin x remains. The problem is okay. So the problem I have taken it wrong. It is not sin cube x cos cube x. It is sin square x cos. Please make a correction. I have copied the problem wrong. It is sin square x cos square x. Because if it is sin cube x, you can't work. The problem I have copied wrong. Now separate it. Sin square x over sin square x into cos square x plus cos square x over sin square x into cos square x. Now you can cancel sin square x. You are left with 1 over cos square x, that is secant square x. Here you can cancel cos square x. You are left with cosecant square x because 1 over sin square x is cosecant square. These two are integrable. Secant square x is tan x. Cosecant square x is minus cot x. because cot x on differentiation gives 1 minus cosecant square x. Therefore, integration of cosecant square x is minus 1. So this we move on to March, July 2016. July 2016. The problem given in July 2016. No, sorry, I have to work one more problem. Because every year they give 2 marks, 2 problems. March 2016, one more problem. The second problem they have given is, they have given a problem definite integral 0 to pi by 2 sin square x by 2 minus cos square x by 2. These are all very tricky problem. You should be familiar with this. So you need to recall the formula cos square a minus sin square a is cos 2a. So if you take half angle formula for this, cos square a by 2 minus sin square a by 2 is cos a. So just to confuse you, they have given sin square a by 2 minus cos square a by 2. So what is that? You can write as a minus of cos square a minus cos square x by 2 minus sin square x by 2. That means it is minus 0 to pi by 2 cos x dx. What is definite integral? Indefinite integral plus one step extra. Now, what's the integration of cos x? It is sin x. Substitute the limit 0 to pi by 2. It is minus of, this minus sign is because of the formula, not integration. Integration of cos x is positive only. Cos pi by 2 minus cos 0. Cos pi by 2 is 0. Cos 0 is minus 1. The answer is plus 1. So with this we shall move on to July 2016 paper. Every year you get 2 questions of 2 marks. Normally the first question will be substitution, but July 2016 it is not so. The problem is different. What's the problem? Integrate x square log x dx. Combination or a product of 2 different types of function is given. The only method is integration by parts. Algebraic and logarithm they have given. So you have to recall the formula of integration by parts. U dv by dx is equal to uv minus integral v du by dx. You need not write this formula and work. I am writing just to help you to recall. First thing is you should realize it's a problem of integration by parts. Here, I'm just repeating it. U is called the first function, dv by dx is called the second function. The first function and second function are chosen in the order I laid, or elate, whatever you want, you can call it. Now you have got x square and log x. What is I? I stand for inverse function, L stand for logarithmic function, A stand for algebraic function, T for trigonometric, E for exponential. Now, algebraic comes after logarithmic. Therefore, you should take U as log x. Now, algebraic is x square, that you should take it as x square. You should differentiate this. You get 1 by x You integrate this, you get x cube by 3. Now use the formula. What is u? dv, it is x square log x dx. What is uv? X cube by 3 log x minus, what is v? V is x cube by 3, and what is du by dx? It is 1 by x dx. So it is x cube by 3 log x minus integral of 1 by 3, you can take it outside, 1 x you can cancel, you get x square dx. That is equal to x cube by 3 log x minus x cube by 9. Why 9? Integration x square is x cube by 3, there already 1 by 3 is there, plus. When you look at the length of the problem, it looks so lengthy, not difficult. So if it is familiar for you, it is not difficult. So one more problem of July 2016. What is the problem? The one more problem they have given is integral 0 to 1 dx over root of 1 minus x squared. No, don't look at 0 to 1. First look at dx over root of 1 minus x squared. You should remember it is sine inverse x. Then put the limit. It is sine inverse 1 minus sine inverse 0. Sine inverse 1 is pi by 2 because sine pi by 2 is 1. Sine inverse 0 is 0. Therefore, it is pi. So we move on to March 2017. March 2017. March 2017. The problem of March 2017 is integral of tan to the power of 4 root x into secant square root x divided by root x. This is another problem, not difficult. You should be familiar with this. Again, substitution method. Put tan root x equals t. It is secant square root x. Secant square root x. Tan is secant square. And differentiate root x also, you get 1 over 2 root x. Dx is t. So write it properly. Secant square root x by root x equals 2 dt. So this will go into dx in that. So this is replaced by secant square root x by root x dx is 2 dt. 2 is a constant, let us keep it outside. Tan to the power of 4 now tan root x is t, therefore this is t to the power of 4 dt. Because tan root x is t, tan to the power of root x, 4 root x, nothing but tan root x to whole to the power of 4, that is t to the power of 4. That is equal to 2 by 5 t to the power of 5 plus c. After integration, replace the value. It is tan to the power of 5 root x plus c. Not a difficult one, but must be a familiar problem. The next problem of March 2017, another 2 marks problem, undefinite integral. 0 to 2 by 3 dx over 4 plus 9x square 4 plus 9x square. While doing revision, I have given you how to work this by taking number of examples. You know the basic formula you need to use is a square plus x square is 1 by a tan inverse x by a plus c. But you notice here, in place of x square, you have got 9x square. So you should consider that as 3x square, or rather 3x whole square. After integrating, you have to divide by 3. The derivative 3x. So that you should remember. And what is a square? A square is 2 square. So it is 0 to 2 by 3 dx over 2 square plus 3x whole square. 1 by a is 1 by 2. 1 by a is 1 by 2. Differentiation of 3x is 3. It is 1 by 6. I've given you the method how to do it directly. Otherwise, you should work the problem, put 3x equals t. Only all that is not required. You remember to differentiate this. You get 3. Supposing it is x square will differentiate x, you will get 1. Similarly, you differentiate 3x, you get 3. So you have divided by that. But how do I get 1 by 6? Because 1 by a is there. And a is 2. Tan inverse. In place of x, you have got 3x. In place of a, you have got 2. 0 to 2. After integrating, put the limits. Upper limit minus lower limit. So this is equal to 1 by 6 tan inverse. It is 1 because 3x by 2 in place of x you are writing 2 by 3. And here automatically it is 0 because tan inverse of 0. So what is the answer? 5 by 20. So we move on to July 2017 paper. July 2017. July 2017 paper. The problem given is a comparatively difficult problem. Root tan x by sin x into cos x. In fact, this problem is in your NCERT textbook, therefore definitely they can ask. But if you are not worked, it is going to be the most difficult problem. Because these problems require skills. What is the skill? You keep root tan x as it is. You divide sin x by cos x and multiply cos x by cos x. If I cancel this one cos x, I am going to get this. So I have divided and multiplied by cos x for a purpose. What is the purpose? This cos square x will go to numerator. It becomes secant square x. Root tan x is as it is. And you are getting sin x by cos x is tan x. See, unless you know this skills, how will you know they are teaching you? How do I know? My teachers are to. This is how the skills are being circulated. Unless you know what to do, you can't do anything. However intelligent you are, unless you know it. Once we know, there's nothing there. Now, what the thing is, you can cancel this, you get root tan x. So it is something like f dash of x over f of x. If you differentiate denominator, you are getting numerator. So put tan x equals to, don't put root tan x as well. Tan x equals to, you get secant square x dx is dt. So this is equal to t to the power of minus half dt. Because secant square x dx will become dt, and this is root t, tan x is t. So what is the integration of this? T to the power of minus half plus 1 over minus half plus 1. That is 2 root t plus c. That is 2 root tan x. You need to remember how we got this problem. Not a difficult one, once you know. So this is skill. You are divide and multiply. If you don't recall that, it's difficult. You can't make out what to call it as. So these are all skill problems. So you need to remember them. So July 2017, one more question they have asked. There's two questions normally they ask. X minus 1 over x minus, no, not x minus 1, x minus 3. X minus 3 over x minus 1 whole square, whole cube. X minus 1 whole cube dx. Sorry, into e to the power of x dx. It's very clear. The moment you see e to the power of x, you have to first check whether it can be reduced to this form. That's the first thing. And normally that will be the answer. Because whenever they ask for 2 marks, they can't ask a difficult problem. They have to ask a problem where this rule we are going to use. But here also it is not in the standard form. So you need to do some adjustment. You write this as x minus 1 minus 2 divided by x minus 1 whole cube divided by x minus 1 into e to the power of x. I'm not telling anything else. Is minus 3 written, minus 1 and minus 2, that is minus 3, separated. So on x minus 1 will cancel, you get 2. Should realize when you differentiate 1 over x minus 1 whole square, you get minus 2 over x minus 1 whole. To differentiate this. How? Let me work it out. So this is 1 over, you can write as x minus 1 to the power of minus 2. This is y. What is dy by dx? Minus 2 x minus 1 to the power of minus 2 minus 1 divided by minus 2 plus 1. So differentiation. Minus 2 minus 1. There is no divided by. We are differentiating this. So x to the power of n is n x to the power of n minus 1. So in place of n we have got minus 2 x to the power of minus 2 minus 1. So if you simplify this, you are going to get minus 2 over x minus 1. Therefore, this is nothing but f of x and this is f dash of x. Therefore, your answer is e to the power of x over x minus 1 whole square. These are all the standard problems which have been repeated number of times. So you need to remember and write it down. With that, we move on to 2018, March 2018. Integral of e to the power of tan inverse x over 1 plus x. Most direct problem. Put tan inverse x equals t. You get 1 over 1 plus x square dx equals dt. So it is e to the power of t dt and nothing but e to the power of t plus c. T is tan inverse x. Most direct. The moment you look at that, you know, tan inverse x plus t, you get 1 over 1 plus x square. This is the second problem of 2018 is x over integral 2 to 3 x over x square plus 1. March 2018 second problem. Integral 2 to 3 x over x square plus 1. See, I think you remember or you can recollect, I have given you a formula. F dash of x over f of x is equal to log of f of x. Yes. So if you differentiate x squared plus 1, we are going to get 2x. But we are got only x. So we can do some adjustment. This is 2x over x squared plus 1 dx. So you have to recall this formula. So this is log of f of x. Log of f of x. F of x is x squared plus 1. Between the limits 2 to 3. Half is outside. Log of 10. Because 3 squared is 9 plus 1 is 10. Minus log of 4 plus 1 5. That is half log 2. That is the answer. Because log a minus log b is log a by b. Supposing you don't know this formula, what is the method? The method is put x square plus 1 equals b. You get 2x dx equals dt. X dx is equal to half dt. So you will get half dt by d. What is dt by d? It is log t. What is t? X squared plus 1. So if you know the formula, all these steps can be avoided. So what was the formula? I am writing again. F dash of x over f of x dx is equal to log of f of x plus. Otherwise, you have to write the steps and work it out. Now we have to move on to the next problem. They have given, that is July 2 problems are over. So we have to move on to July 2018. July 2018. Integral of cos 6x into root of 1 plus sin 6x. Most direct problem. Put 1 plus sin 6x equals to cos 6x dx is 1 by 6 dt. I am shifting 1 by 6 here to save time. So 1 by 6 is a constant. This will become 1 by 6 dt. So this is t to the power of half dt. 1 by 6 into t to the power of half is t to the power of half plus 1 by half plus 1 plus 6. See, what will happen is 1 by 6 into 3 by 2, because half plus 1 is 3 by 2. If you simplify this, you get 1 by 9. 1 by 9 t to the power of 3 by 2 plus. The problem is not over. What is t? 1 plus sin 6x to the power of 3 by 2 plus. Most direct, but you have to be careful. Sometimes we go wrong in the simplification and lose our mind. Next, July 2018, second problem. The problem is x e to the power of x e to the power of x over x plus 1 whole square. Same thing, e to the power of x into f of x plus f dash of x format. What's the adjustment you have got to do? Write this as x minus 1 plus 1, sorry, x plus 1 minus 1 divided by x plus 1 whole square minus x plus 1 whole square into e to the power of x dx. I have added 1 and subtracted 1. Now, simplify this. You get 1 over x plus 1 whole square minus, no, 1 over x plus 1 because 1 x plus 1 will cancel, minus 1 over x plus 1 whole square into e to the power of x. This is f of x, this is f dash of x, e to the power of x over 1 plus x plus. Very, very simple problem, provided you remember the method. We move on to March 2019 paper. March 2019. March 2019 paper. What's the problem? Integrate dx over cos square x into 1 minus tan x whole square. Another tricky problem. You have to write this as secant square x over 1 minus tan x whole square. Put 1 minus tan x is 2. You get secant square x dx is minus dt. And should keep the minus sign. So it is minus dt by t square. That is minus t to the power of minus 2 dt. That is minus t to the power of minus 2 plus 1 by minus 2 plus 1 plus c. Get a minus sign here. 1 by t plus c. 1 by 1 minus tan x. I found it very fast because it's a familiar problem. Only thing you should realize, purposefully they have given cos 1 over cos square x. That should be substituted as numerator and make it as secant square x. And tan x on differentiation gives secant square x. It's a direct problem of March 2019. Second question. Integrate sin 2x cos 3x. Here we have got the formula sin A cos B or cos A sin. Whenever you got to use the formula either sin A cos B or cos A sin. I would rather suggest whichever is bigger, you call it as A so that you can avoid the minus sign. So rewrite the problem as cos 3x sin 2x. Repeat. You have to use either this or that. Purposefully they have given bigger one later. And the student may use the first formula. Then you take A minus B, get a minus sign. Then you need to use the allied angle formula and all that. The best method is you take A as a bigger number. So once we realize, so we should recall the formula. What is the formula we are using? Cos A sin B. What is cos A sin B? Sin of A plus B minus sin of A. So if you use that formula, of course, divided by half is there. Half of this. So half is outside. Integral of Sin of a plus b is sin 5x. Sin of a minus b sin x. dx. Once you use the formula, it becomes so easy. Half is outside. Sin 5x is minus cos 5x by 5. And sin x is plus cos x because minus sin x is plus cos x. So with this, we move on to see July 2019 problem is slightly difficult, but I will run the problem. I don't know why they, of all the years, that was the year where they give a very difficult problem. We should not leave it because when you are aiming for it, we cannot take chances. The examiner might repeat the same problem. So we will work it out. It takes a little more time. So I will try to go as slow as possible to see that you understand the concept clearly. The problem is x to the power of 4 integral of x to the power of 4 minus x to the power of 1 by 4 divided by x. X to the power of x to the power of 5. Okay. Divided by x to the power of 5. This is another important problem where you need to use a scale. So you do one thing. You take x to the power of 4 common here. This. You get 1 minus 1 by x cube. Whole to the power of 4. 1 by 4. Why? X to the power of 5 dx. Entire problem trick is here. So x to the power of 4 minus, whole to the power of 1 by 4 is x. X into 1 minus x cube to the power of 1 by 4 dx divided by x to the power of 5. So if you cancel, you get x to the power of 4 here. But we write this problem as x to the power of minus 4 into 1 minus 1 by x cube to the power of 1 by 4 dx. I repeat what I have done. It's a very tricky problem. What skill they have used, if you have not worked this earlier, definitely you cannot work. So you take x to the power of 4 common. So you get 1 minus 1 by x cube whole to the power of 4. X to the power of 4 to the power of 1 by 4 is x. Now cancel, you get x to the power of 4. So we have taken numerator. Now what we do is put 1 minus 1 by x cube is equal to 2. You can write as 1 minus x to the power of minus 3 is equal to 2. Difference here 1 is 0. What is x cube? Plus 3 x to the power of minus 3 minus 1. Because x to the power of n is n x to the power of n minus 1. So n is minus 3, therefore it becomes plus into dx equals dt. So this is x to the power of minus 4 dx is 1 by 3 dt. So what will happen? X to the power of minus 4 dx is 1 by 3. This is t to the power of 1 by 4 dt. That is 1 by 3 t to the power of 1 by 4 plus 1 or 1 by 4 plus 1 plus c. If you simplify this, you get 5 by 4, 4 will go to numerator. So it is 5 by 15. 4 by 15. You understand this? 1 plus 1 by 4 is 5 by 4. 4 will go to numerator. 5 gets multiplied. E to the power of 5 by 4 plus 6. That is 4 by 15. What is t? 1 minus 1 by x cube to the power of 5 by 4. One good thing about this is there was only 1 year, that is in June 2009, July 2019. Afterwards, they were not asked. The next problem of the same year, I don't know why the examiner was so adamant, or we could say, or wanted to give a difficult problem, more than difficult problem, same year. Other problem given is x secant square x dx. Difficult in the sense which involves more steps. This problem, the moment you see the problem, you should realize the product of two functions. Whenever you notice the product of two functions, what is the method? You need to use integration by parts. So here, what is your first function? You have to use the dilate. Algebra, x comes first, trigonometry comes afterwards. Therefore, u is x. dv by dx is secant square x. du by dx is 1. I told you that in no need of writing the formula every time. You can remember the formula and work it out. Integration of secant square x is tan x. So what is your answer? X secant square x dx is equal to uv. uv is x tan x minus v du. du is 1 minus tan x dx. X tan x minus log secant x. This particular year, the examiner wanted to give some difficult problems. I think that year most of the students have last marks, especially in the first problem. That's the only year they asked that. Anyway, I have given you the method of working. Remember that in case if it is repeated, you should be able to work. So with this, we move on to March 2020 paper. March 2020. The problem given in March 2020 is cot x into log sin x. Cot x, very simple if you realize. See, one clue for you is almost every year they give a problem substitution method. Maybe 1 or 2 years they have changed. So let us think in substitution method. If you put cot x, you will not get log sin x. But if you put log sin x as t, you get cot x. How? Put log sin x equals t. To differentiate this, 1 over sin x into cos x dx. Another easy method is, integration of cot x is log sin x. Therefore, difference in log sin x should be cot x. So, but you have got to show the working, put log sin x equals t. So, what is this? Cot x dx is dt. So, this is going to be cot x dx is dt, log sin x is t, it is t dt. So, very simple one. T square by 2 plus c, that is log sin x whole square by 2 plus. The second problem in that year, March 2020, is they have repeated what was asked in the previous year. I have just now about, I am skipping this problem. X secant square x by integration by parts. We'll see how many problems are repeated as it is. With that, we'll move on to September 2020, because in March 2020, exam was not held because of Corona. September 2020 problem is a very simple one. I don't know why they gave that problem here. Anyway, very easy or difficult. E to the power of x into secant x into secant x plus tan x. You just multiply secant x inside, you get secant square x plus secant x tan x. Sorry, not secant x, 1 plus tan x. But is secant, you secant square x in secant x into secant x tan x dx is 1. So this is f of x, this is f dash of x. Therefore, answer is e to the power of x into secant x. So they have given 1 plus tan x. So secant x into 1 is secant x, and secant x tan x, this f of x, f dash of x. Therefore, we get this solution. So September 2021, I will not work that problem because it is sin 2x into cos 3x. They could have at least altered the numbers, they have not altered it, they have given the same problem. I repeat again, always choose a as a given number. So use the formula cos a sin b, not sin a cos. Even if you use sin a cos b also get, but then you are going to get sin of minus theta there. Then you got to use allied angles. To avoid that, whenever you sin a cos b or cos a sin b or sin a sin b or cos a cos b, always see that a is greater than b, so that you can avoid the minus sign. So no matter working that problem, we'll move on to September 2021 second problem. It's a very tricky problem. E to the power of 5 log x minus e to the power of 4 log x divided by e to the power of 3 log x. Problems look too difficult, but it is not so. Dx. The only formula you should remember is e to the power of log of f of x is equal to f of x. Other formula you need is n log m is equal to log m power n. See, if you use these two formulas, this problem becomes very easy. This it is e to the power of log x to the power of 5 minus e to the power of log x to the power of 4 divided by e to the power of log x cube minus e to the power of log x square. I am using this formula. Now I am going to use this formula. So this is equal to x to the power of 5 minus x to the power of 4 or x cube minus x square dx. You can take x to the power of 4 common. You get x minus 1. You can take x square common. A very, very simple problem, provided you have worked earlier, not otherwise. You cancel, you get x square. That is equal to x cube by 3. When you look at the problem, it looks difficult, but it is not so. April 2022, both the problems I will not be working because they have repeated the problem. April 2022 problems. The first problem is x square log x, which I have worked. The other problem is sin square x over 1 plus cos x. These two problems we have worked earlier in July 2016 and March 2014. So we will move on to the next problem of August 2022. Because that year we had pre-examination 2022. The problem given is sin 3x cos 4x dx. Again notice cos is greater, so write the formula as cos A sin B. So once you write like this, I have given you the formula. The earlier problem was sin 2x cos 3x. So same thing, only thing is values have changed. You can work it out yourself. That year, they are given 3 problems. In August 22, they are given 3 problems. One is this, other one is tan to the power of 4 root x secant square root x by root x. This problem I worked it out earlier. I will skip that. So the next problem, 0 to pi by 2 cos square x dx. We have not worked this, but very simple. You have to use the formula cos square a is 2 cos square a. I shall go for the basic formula itself. Cos 2a is 2 cos square a minus 1. So cos square a is half of 1 plus cos 2a. Similarly, one more formula is that sin square a is half of 1 minus cos 2a. So depending on that, use the formula, its cos square x is given half of 0 to pi by 2 1 plus cos 2a cos 2x dx. Now this is half is a constant. Integration of 1 is x 0 to pi by 2. Cos 2x is sin 2x by 2 half outside. Sin 2x 0 to pi by 2. Half is there outside. Is pi by 2 minus 0 plus half outside. Sin pi minus sin 0, both are zeros. Therefore, answer is pi by 4. In fact, this can be a CET question also, 0 to pi by 2 sin square x. It's also equal to cos square x. Both are pi by 4. We move on to March 2023 paper. 2023. The problem given is 2 minus 3 sin x. 2 minus 3 sin x by cos square x. In fact, I worked this problem in the revision class also. Not a difficult one, separate it. We get 2 secant square x minus 3 tan x into secant x. So when you separate it, you get 2 cos square x and 2 secant square x. So 1 cos x you give it to sin x by cos x, tan x secant x. You can directly differentiate this secant square x is tan x, 2 tan x, secant x tan x is secant x, 3 secant x. Very, very simple problem. Only thing you should be able to express it. This is next problem is 1 to root 3. 1 to root 3 dx over 1 plus x square. You know it is tan inverse x. 1 to root 3 tan inverse root 3 minus tan inverse 1. What is tan inverse root 3? Tan inverse root 3 is pi by 3. Sin 60 by cos 60 is root 3 by 2 divided by half. So this is pi by 3 minus pi by 4. 12 is the LCM. So you get 4 pi minus 3 pi, that is pi by 4. We move on to June 2023. The problem is sin 4x, sin 8x. Sin 4x, sin 8x. You have to use the formula sin A sin B is equal to half of cos of A minus B minus cos of A plus B. Take A as 8x, B as 4x. Can complete that, so I will not be wasting time on that. The next problem they have asked, we have already worked it out. No, another problem is 0 to pi by 4 log tan x they have asked. 0 to pi by 4 log tan x they have asked the question. 0 to pi by 4 log of tan x. So what's the integration of log tan x? Log secant x is tan x. Log tan x. This is a, maybe my mistake, it has come, will not work that. Or some. We'll go to the next problem. That is already worked out. Dx over cos square x into 1 minus tan x whole square. Already worked out problem, no need of working. So with this we move on to the next problem of 2023, x sin x dx. What's the problem? Integrate x sin x dx. See here, it's a product of two functions, integration by parts. Algebra first comes, then trigonometry comes. Therefore, put u is equal to x dv by dx equal to sin x. Du by dx is equal to 1. V is equal to minus cos x. So use the formula uv is minus cos x minus v du is equal to plus sin x dx. Index into 1 into dx. 1 is du by dx. So this is minus x cos x minus cos x. Why? Integrate sin x is cos x. Next, we move on to June 24 paper. In June 24, the question they have asked is pertaining to partial fractions. X over x minus 4 into x minus. Now, what is the first step? Whether it's rational or irrational. How to do that? Degree of numerator is 1, degree of denominator is 2, rational. For second step, factorize. Factors are non-repeated. So you write this as x over. I have explained you the method. You have to follow that. In revision class, I have explained you the method. You can go through that video in case you have missed it. For every non-repeated factor, one constant. These two are two non-repeated, two constant. We are using partial fractions. Multiply by LCM. X minus 2. I have explained this in detail in one of the videos. Partial fraction, go through that. Put x is equal to 4. 4 is equal to 2a. A is equal to 2. Put x is equal to 2. 2 is equal to minus 2b. Therefore, b is equal to minus 1. So you are writing this as a. What is a? Is 2. Dx over x minus 4. What is b? Minus 1. Dx over x minus. This is 2 log x minus 4 minus log x minus 2 plus. I have worked out partial fraction in detail. Therefore, I am not working. If you have not seen that video where I explained what are the different steps. First step, I just repeat. First step is to see whether it's proper or improper. Second step is factorizing. After factorizing, you should see whether it is a non-repeated factor. Based on that, you have got to assume the constant. Third step is multiplying by LCM and getting an equation. Then you have to get these constants assumed. You have to either give particular values just like I gave here, or you can equate a coefficient. I have got all types of problems with that, so I am not wasting more time on this. And July 24, there was a similar problem. I will not be working that. It is x minus 1 into x. X plus 1 into x plus 1. Instead of x minus 4, you have got x plus 1. Instead of x minus 2, you have got x plus 2. Can you complete that? The next problem is 1 to root 3 dx over 1 plus x square. It's a repeated problem, you already done that. Then there are 3 model papers. I'll just complete those problems and stop here. 2 marks questions. So that tomorrow I will take up 3 marks questions, and in case if I get time, I will move on to 5 marks questions. Okay? So model paper 1, the question is sin 3x cos 4x. No need of working. The sin A cos B formula, cos A sin B, because A is written. Cos A sin B formula, when A is 4x and B is 3x, you can complete it. Next, model paper 2. X cube minus x square. X cube is another very tricky problem. X minus 1 divided by x minus 1. It's a very tricky problem. You just take x square common here. You get x minus 1. You take 1 common, you get x minus 1. X minus denominator remains as it is. Now take x minus 1 common. You get x square plus 1 by x minus 1. These two will cancel. You get x cube by 3 plus x plus 1. Very simple if you can realize this, or if you have worked out this. Another model paper that also I am not going to work. It is x square plus 1 into log x. So put u as log x and dv by dx and x square plus 1. It's integration by parts. So with that I have completed all 2 marks questions from paper number 2014, 2024 and also model papers. Now, what you can do is, you can go through all the problems, whatever are there, keeping the paper with you. In case if you want me to repeat any problem or any concept that you have got doubt, I shall attend to that first. Because tomorrow what I have decided is, whenever I find time, maybe I may start a little early, also not, I may not wait till 7 o'clock. And I will start with 3 more questions. Then I will, in case if time permits, I will go for 5 marks questions. 3 marks and 5 marks. After that, we have got this last part, P part, where there are 6 questions, 6 marks questions are also sometime asked in the from integration. Whatever problems they have asked earlier years, that I am going to work. Because if you see the question papers, you find number of problems are repeated as it is. So we'll try to solve all the questions. After completing integration questions, I will take up differential equation. So our last class when 24th, that time whatever possible we shall complete. So we shall close the class today. Thank you. Shall meet tomorrow.